John Shaw, founder of Quantum Computing. John, an executive technology leader in digital transformation. John has 20 years experience delivering technology solutions in healthcare, fintech, logistics, manufacturing, energy and utilities. John is an expert at building successful relationships, capabilities and culture. He excels at bringing out the best in people by listening and sharing the big picture. Operating with an agile decision-making style, he will rapidly catalyze change by turning ideas into actions. John Shaw, you're very welcome. Thank you for joining us, and we look forward to hearing about digital wellness.
Thank you. So let me see now. Hopefully I can show my slides. Okay, right. My slides are moving. That's good. What I want to talk about today is quantum computing, and when we talk about digital wellness, the impact that quantum computing is going to have in healthcare. So when we talk about digital wellness, we're talking about how digital technologies are going to start making a major impact, an increasingly beneficial impact in healthcare. So I want to leave you with three thoughts at the end of my 20 minutes. Firstly, digitization is already disrupting our world in major ways. Quantum computing is the latest technology to bring better ways of working. And by 2030, quantum computing will be accelerating vaccine discovery timelines. It'll be assisting in predicting pandemic outcomes, and it will lead us to a better and a healthier world. So, quantum supremacy. Back in October of last year, a major breakthrough was achieved in the world of quantum computing. A team of Google engineers using a quantum computer were able to execute a task in 3 minutes and 20 seconds, which, if that same task was performed on a conventional computer, in fact, if it had been performed on the world's most powerful supercomputer, would have taken approximately 10,000 years to execute, 5.2 billion minutes. 3 minutes versus 5.2 billion minutes. So there's definitely something about quantum computing that we all need to hear about, understand, and then see how can it affect our own businesses, our own context. So I'll talk about this by beginning with a look at accelerated digitization, and then move on to the more specific topic of quantum computing and how it will affect healthcare in the years ahead. So today is the 21st of October, 2020, only it's not. We're in 2025. Today is actually 21st of October, 2025. COVID has pushed us 5 years into the future. Everybody is working from home. All our staff, all our customers, where they can, they're working from home. Digitization has massively accelerated since this COVID pandemic began. And our health, our wellness is now a priority for our families, for our parents, for our children, for all our loved ones and our neighbors and friends. We are now acutely aware of our health. And of course, healthcare costs have been rising for years. In fact, this year, the US is on track to spending 25% of its GDP on healthcare, about $10,000 per capita. So COVID-19 has exposed significant weaknesses in how the world approaches healthcare. Before COVID, we would have thought about risk in all our businesses, but the kinds of risks that we would have been thinking about would have been things like cybercrime and increased regulatory demands, perhaps. But the black swan event of COVID-19 blew all of those risks out of the water in terms of scale. Also before COVID, the world was already spending a lot on digitization. In 2019, about 3.7 trillion US dollars, with over 5 million smartphone users across the world and nearly 4 billion active social media users. So digitization was already disrupting. COVID has accelerated that disruption. Controversially, Gary Vaynerchuk 2 years ago said that within 5 years, the shop is dead in North America. And indeed, long before COVID, many shopping malls in America were seeing declining visitor numbers. The Stone Age didn't end because they ran out of stone. Things come to an end for all kinds of reasons. Online shopping has taken over more and more, and COVID has accelerated that trend. Another trend, telemedicine. So back in January, in the US, about 11% of people would receive their GP consultation over Zoom. That number is now closer to 50%, and it's on track to being 80% by the end of the year. So indeed, the future is already here, only it's not evenly distributed. COVID has been the most disruptive event since the Second World War, but some organizations were there ready to help their customers in a time of immense stress. I mentioned Zoom. Microsoft is another company that has given huge value to organizations in this time. Netflix have seen record-breaking profits, and Amazon now have 4 warehouses in Ireland and are soon to begin to launch their vehicles on the road. We'll soon see the Amazon trucks in Dublin. So digitization has been driving huge economic change for quite a while. Within a decade, China will be the world's largest economy in GDP terms, and India will be number 3. And essentially what's happening to China and India is that they are returning to their natural state of being the 2 largest economies in the world, which they were for most of human history, certainly up to 1600 AD. And the education, the STEM education right across the world is a major contributor to this. So we don't simply compete now with the organization 5 kilometers away or 50 kilometers away. We're now competing in a world 24/7, and your competitor can be anywhere. Digitization means that distance is no longer a barrier for any service that you might need to get. So quantum computing is arriving in this world of major disruption. COVID has accelerated trends already well underway. So quantum computing is now the technology that can take a certain class of problems to a more efficient solution. Quantum computing exists within the broader field of applied quantum mechanics. Now, I'm not going to use the 20 minutes to talk in depth about quantum mechanics, but already research is well underway in a whole range of fields around quantum mechanics and its application in business. The entire field is just over 100 years old. Max Planck won the Nobel Prize in Physics in 1918 for his work on this field. Essentially, we live in a universe built in peculiar ways. We have I suppose an instinctive understanding of basic physics, gravity, and the sun comes up in the morning, the earth goes around the sun. We have a basic understanding of physics. But when you look at things that are very, very small or very, very large, you see other strange things that are beyond your intuition or your instinctive understanding. And quantum computing avails of that strangeness. Specifically, if we compare classical computing, all our mobile phones, all the technology being used today for this conference, it's all based on binary logic, 1s and 0s. All the calculations are based on that principle. Quantum computing avails of a peculiar aspect of reality, which is that you can form the calculations based on probabilities, a probability surface, rather than 1s and 0s. And this field is less than 20 years old. From a computing hardware perspective, but it's utilizing a reality that's beyond normal perception. And for a long time, it was a curiosity rather than something that could have practical application. But more recently, organizations like D-Wave, based in Vancouver, have been building machines that are becoming faster and bigger, more powerful. Quantum computing uses a branch of mathematics and a branch of physics, which allows calculations to run hundreds of millions of times faster than conventional computing. An organization which is making this hardware more accessible is an organization. There are many organizations, one of which is Horizon Quantum Computing, based in Singapore, run by an Irish guy, Joe Fitzsimons. And his mission, his company's mission, is to allow us to use quantum computing in a way without realizing it. So it's presented to us in familiar apps on our smartphones or on our PCs, and the calculations are being performed somewhere else in a way that we don't need to understand. So this would be equivalent to the reality that most of us don't actually understand how a conventional computer works, but we know how to use the software. And in the same way, making quantum computing accessible is going to be a big part of the challenge. Making the software easy to understand and use and get business value from, rather than confuse everybody with the hardware. So what are the kinds of things you can do with a quantum computer? Well, for example, Volkswagen are currently running a project in Beijing to optimize a taxi fleet's routing plan. Now this, for those familiar in the world of writing code, this would be known as the traveling salesman's problem. Now that sounds like maybe a simple problem to solve, but in fact, it's a very, very difficult problem to solve on conventional computing. For example, if a company had 20 shipments on 4 delivery routes, there are actually 1 trillion possibilities for a computer to rank in terms of trying to optimize which is the best route to pick. And if you add more routes and more shipments, it becomes increasingly difficult and indeed near impossible for a classical computer to run the algorithm to a successful answer. So quantum computing is going to be focusing in on these types of problems to save businesses money in the logistics costs and delivery costs. Overall, there are 5 domains for use cases with quantum computing. The early focus is going to be on things like chemistry, how complex molecules interact with each other. Very, very difficult to model on classical computing. And then from there, we'll move on to optimization type problems like the one I mentioned with Volkswagen, and then machine learning problems, material science problems, and then move on up into problems we can't even imagine. So the analogy would be with electricity. So electricity in 1900 was a new thing. The early electric kettles looked very like stove kettles. But by 1960, electricity was powering television and computers, things that would have been unimaginable in 1900. So in the same way, quantum computing opens up the possibility to solve problems which we can't even easily describe right now. So how fast is a quantum computer? Well, one way to answer that is to think about the analogy between how fast is a car and how fast is a jet aircraft. So your car is very useful if you want to drive down to the nearest shop to get a newspaper, but it wouldn't be a very useful thing to travel across the Atlantic or go further afield. A jet aircraft would be a pointless device to use to go shopping for a newspaper. And in the same way, quantum computing comes into its own for a certain class of problems where you're dealing with very, very large computational challenges. So when you look at, for example, number factoring, when you get above a certain number of digits, around about 1,000 digits, classical computing becomes highly inefficient. And quantum computing is able to get answers in seconds and in a few minutes, which would take millions of years with a conventional computer. The kinds of benefits we're going to see things like faster DNA sequencing. We're going to see predictive health, faster discovery of new drugs, better decision support. We're going to see other things that we can't, as I say, already imagine, because it opens up possibilities. As people move into the sector and get to understand it, they'll start to see other challenges that can be solved. 2 examples of algorithms. Just to talk about the mathematics briefly. Just as the physics has developed, that we can now build the hardware, without the mathematics and without the algorithms, the hardware is kind of useless. And Grover's algorithm is one of the 2 main algorithms currently available for quantum computing platforms. So this is a way to calculate the mean of a large set of numbers. So we can all do that on pen and paper for small quantities of numbers, and classical computers can do it for reasonable amounts of numbers as well to calculate the mean. But when you get into very, very large sets of numbers, you need a different mathematics to solve the problem. So you have a different mathematics with different hardware. So think about it in this way. You need to have software from somewhere like Horizon Quantum Computing Company to show you the world of quantum, how to interact with it. But you need to have an understanding of the mathematics to make sense of how to write the algorithms, and you need to have the hardware using the quantum mechanical effects to get a result. So these three layers have to work together to achieve this. Another example of an algorithm is an algorithm for decrypting encrypted data. So when you're using WhatsApp, all the data is encrypted. The most conventional way to do encryption in the modern world is with 2048-bit encryption. Sorry to sound technical for those who don't know the background on this, but the significant point is that a quantum computer can crack RSA encrypted code in 36 minutes, which would take 300 million years to crack with the fastest conventional computer. So there's definitely something to watch out for here. So the next wave of cybercrime perhaps will avail of this type of technology. So you get into an escalation war that if you're not encrypting using quantum encryption, you're exposed. Therefore, as a new technology emerges, unfortunately, nefarious players come into the play as well. So in healthcare, how can quantum computing help? Well, if you look across all of the technologies that are emerging to improve digital wellness, quantum computing is one of those. Quantum computing is something which is being toyed with for vaccine discovery, for analysis of how different chemicals interact, but it's going to become mainstream within the next 5 years. When you look at use cases overall for quantum computing, there are already, in North America, there are already over 50 organizations who currently derive income from providing quantum computing solutions, mainly in financial services. But if you look at this league table, you can see how the pharma sector is moving into this as well, and also for medical devices. So we're going to see a lot more use cases emerge as more and more people become familiar with the technology, and as the technology becomes more reliable, and as the quantum computing machines become bigger and faster. So, for example, if we take drug discovery and genomics, I mentioned already, simulating chemical interactions is very difficult at the moment. Typically, researchers might spend 12 years comparing interactions and effect of different drugs on a range of diseases. And that's why most drug discovery is performed in what's known as a wet lab, the traditional cycle. Being able to digitize that is very difficult with classical computing. In fact, it's not possible. Similarly, when we talk about looking at possible gene variants, a quantum computer can look at vast numbers of possibilities in seconds or minutes in a way that isn't even possible on a classical computer. As the famous Richard Feynman said, nature is based on quantum mechanics. So to simulate nature, you need a quantum computer. So what's next? What's coming next? Well, quantum computing is becoming faster and faster. The first machines emerged in the late 90s, 2-qubit machines in a research project at MIT. But we're now getting into machines that are up at 128 qubits and beyond. The Google experiment I mentioned earlier was conducted on a 54-qubit machine, for example. I mentioned that problems of today that quantum computing will solve will be the problems that we're familiar with on classical computing, such as cryptography, financial services, optimization problems, logistics optimization problems. But as you move further and further into the future, the kinds of problems that will be solved are beyond our current limit of thinking. And in relation to revenue, I mean, this is not a huge industry currently. So last year, the total revenue in this sector would have been in the region of about $120 million. Within a decade, that's estimated to grow to about 9 billion as more and more organizations adopt the technology. So to get involved, we have a group, Quantum Computing Ireland. We have about 85 members. And these are people who are, I suppose, initially enthusiasts or people who are thinking about this for their business, and in particular, the healthcare sector. And you're very welcome to join that group, our group. So in conclusion, digitization is already disrupting our world. Quantum computing is the latest technology to bring better ways of working. And within a decade, quantum computing will be having a big impact on digital wellness. Thank you.
John Shaw, founder, Quantum Computing. Thank you very much for your contribution and your insights. It's been, I suppose, it's commonly discussed that COVID has accelerated research, it's accelerated technology, innovation. You've put a number on it, 5 years, so we're living in the future.
Yeah, absolutely. We've seen more changes in organizations in the space of 3 or 4 months than could have happened in 3 or 4 years. Look how fast everybody adopted Zoom. Look at how Amazon's business has leapt forward. It's incredible how businesses have had to adapt. So it's a time of great disruption, but there is no going back to the world of before COVID. You know, the Stone Age didn't end because we ran out of stones. So there is no going back. Yeah. The Steam Age didn't end because we ran out of steam. Right?
Yeah, and it's incredible. You know, COVID, it's created a lot of pain, a lot of sadness, but it's also, there's been a lot of, benefits as well. And, every cloud has a silver lining, but it's not taking away the seriousness and the sadness that it's caused. John Shaw, thank you very much for your contribution. You're going to...